Welcome to my demo timesheets of my PowerShell moves data around project. We need a normal PowerShell change to the directory where I've installed all my project files. And in this demo, I will use the ISE just because I want to show that it still works with PowerShell 5.1. So we open this up. Let's see, here it is. But we also need the Docker containers to be started. So let's run the 99 start. This will start the VSL2 in the background and run my Docker Compose up. And in just a few seconds, the Docker containers should start. Here we go. All containers are running and we are inside as root inside the VSL2 on a command prompt. If we exit out here, the Docker container will stop and the VSL will stop. So we leave this open the whole time and now use our ISE. Okay, let's make it a little bigger. So yeah, the break command is just if you accidentally run the whole script, nothing happens. I will change the prompt to have a small prompt and change it into the demo directory. So here we go. Always use error action preference stop with all scripts, so in here as well. First of all, what demo data do we have? Let's see. Here in the timesheets, data timesheets directory, we have 3 Excel files. Let's have a look what's inside there. Just move this here. And here we are, a little bigger. So a typical timesheet with what date, what time from to, and what project and what task. It's not, it's just for demo purposes. And we see that we have a person A and a person B. Yeah, not very much in here. But if we look at maybe the other one, there's a little bit more data in there. Yeah, here we go. Person C and person D, yeah, they work a little bit more. Okay, now we know what data we have, but we want to have the data inside of our PowerShell and later on inside of our SQL Server. So we use the import Excel module. To install it, use install module. If you have admin rights, this, or non-admin rights, then you can run it with scope current user. I've already installed it, so I can run this command and import the module. And then we have a command that's import Excel. We need to tell them what data. Yeah, this is the Excel file. What worksheet? Yeah, let's start with person A. As we've seen, there is a header, and so the start row is in row 3. Say, okay, definitely treat as date columns in case the automatic doesn't work, just for safety reasons, date, time from, and date to, and only import the data, no empty rows. So let's run this, and we have the data. Let's see what we have. If I just run this and have a look at the data, you see the two Excel lines here a little bit different. Now let's get a little bit into PowerShell. We can, with get type and even get type full name, we can see what kind of object we have. We have an array of objects. If we take the first object in that array, we see it's a PS custom object. And inside of that, we have the date. and that's a date time. So we have not only strings, like if we're importing CSV files, but we have the correct data type. PowerShell can present us the data as a table. It looks a little bit like the Excel version. But we have more information. We have the department as the name of the file. Yes, later on we can list all Excel files in the directory and get the department from there. And we have a person as the name of the worksheet. And yes, we can get a list of all worksheets in an Excel file. And we have to calculate some data. If you have a look here, then the date is the date and time 0, and the time from has kind of an interesting back date, and we want to get this time portion from that. We have to do that later on. I'll show you how. So first, let's talk about the data, the target data structure, and create the table on the SQL Server. So let's scroll up here. So we have the department, just a varchar, a person. We have the start and the end. Yeah, in the next refactoring, I'll probably do not use end as the name of the column, but that's for now. A project and a task. So we have 6 columns, a primary key constraint, and we're good to go. So we put this create table in a variable. And now we need to create the table, but to create the table, we need to connect to the database and execute the query. To connect to SQL Server and other databases, some lines of PowerShell are needed. All this is hidden in some functions, and I will import these functions there in the lib directory. And we also need for the connection a password, a username and password. On the SQL Server database, we have the username Timesheets, and the password is here in the demo password. And one thing I like about PowerShell is that we can safely work with those passwords, because we get this pop-up and can enter the password here without seeing it on the screen. Just if it's really public, another way, not interactively, but in the script, to create such a credential is this here, just for demo, for documentation. And now we can open the connection. This is one of the commands we imported here up there. Connect SQL instance. What instance? I'll use the localhost IP address to force it IP4, and use this credential with the username and password, and say we want to connect to the database timesheets. So let's see if this works. Take some time to spin up the SQL database because it's sleeping. Okay, and it's up and running. And now we can create the table. It works. So the table is created. Okay, next step. Now we know what data we have and how the target table looks like. So now we have to prepare the data, the T in the ETL, extract, transform, load. We will, let's upload here. Let's start with the first row. Let's see what we have in row. Here is the row with the date, time from, time to, project, and task. And next step is to have individual variables with all the needed information, 6 columns, 6 variables. So we imported this from the department A, from person A, and now we have to calculate start and end. And we have our time from, and we can just get the time of the day and do not leave the year. And we have this. It's a structure. We just need total hours. Okay, 8 o'clock, it's 8 hours from the start of the day. And these hours we can add with add hours to the date. So when I execute this, start is 2nd of January this year, 8 o'clock. Same with end and project and task. We'll do it not only once, but more times, telling you what's bad, what's better, what's best. So we start with a bad idea. We can just concatenate strings to have the insert statement. PowerShell uses can use double quotes with variable expansion. So if I run this and have a look at the query, it's insert into DBO Timesheets, and we have the string with the data. Does it work? Let's see. It works. And we can get the data back from our database. But we have some problems. Exploit of a mom. Have a look at this comic. We'll skip this here. And we get a lot of execution plans because there are a lot of different statements. The better way is to use bind variables. Let's put this up here. First of all, let's truncate the table so the data is not there anymore. Let's change our insert query. Our insert query is now insert into timesheets, and we have these variables in SQL Server. We have it with the @ sign. In other database systems like Oracle, we have colons. And we need a hash table. This way we create a hash table with the different names of the variables and their value. So we need this as well. And then the invoke SQL query has parameter values, which takes such a hash table, and this way we can run the query and send the query to the database and the bind variables. So in the statement cache, we only have one statement, and it's totally safe. Let's see. Yeah, there's the data back from the database. And the best, use bulk insert. Let's have a look at these insert parameters. This is a hash table, so we get a name and value structure back. We can cast this to a PS custom object. Then we have kind of a structure that we already know. And we need an array with this one element and put it in data. And then we can use another command, write SQL table. Our connection, or the name of the table, DBO timesheet, the data, here, this array of PS custom objects, and we have an optional parameter, truncate table, so we don't need to truncate it. We can just truncate the data and write it and get it back. And now we can iterate over all Excel files and iterate over all worksheets and iterate over all rows to generate a big array of PS custom objects with all the data that we want to import. I don't want to show you the PowerShell code for that. I just created another function, command that is named import XLS timesheets. You find it in the demo directory and can have a look at the code. And now we can just use this as the path. We say, okay, all department, blah, 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 XLS. we want to import. That takes just under a second. From our table, yeah, here's all the data, and we even have a way to show this more nicely with, let's see, there it is, this out grid view. I like this grid view and want to show it to you because what we can do is like have a look at the data and filter like testing. So if I have TE, I get all the rows that have T and E somewhere inside, not only in the specific column, but somewhere, and can easily work with the data and can even sort the data up and down or by project, etc. So we have the data in Excel data, and now we can use our write SQL table again and wrong command, and insert it into the database and get it back out. You see, it's really lightning fast. As we now have a lot of data in the database, we can select the data and create a report and create an Excel file, just to show you that I can not only read but also write Excel files. Let's scroll this up a little bit. I have two queries, a project query and a date query. If we have a look at the project data, I have the project minutes worked per project. And if I look at the date data, scroll it up, I have for all the different days, date minutes worked. So how long did all the employees together work? To create Excel files with charts, we need to configure this. I don't want to go into detail here about the different configurations. I will just execute this. If I want to rerun it, I can remove it. I don't need this at the moment. So I can just have my project data and my date data, and I can pipe the project data into export Excel. And I can export the date data into the same Excel file. Minus show will just open the Excel file here, and here we go. And as you see, the charts are rendered on the first opening of the file. And here we are. We have the two tables and the slides. Okay. Let's close this, and we can even import the data back. Yeah, file needs to be closed. So I can run this import and have a look at the data. Okay, I can get back the data. So, key takeaways. Excel is good at storing data, including data types, and that's better than CSV files. If you work with PowerShell and data, all data should be stored in arrays of PS custom objects. Inserts can use bulk insert with some databases like SQL Server and Oracle. There are other databases that do not have the ability to use these bulk insert methods that I use here. But then, you have to work with individual inserts and can use bind variables to optimize this. And PowerShell 5.1 can still be used. All the other demos following this demo will use the current PowerShell 7.5. And just to clean up my directories, I can clean the Excel file I generated, and I can clean the table, and then I can start again. I will close this demo, and just to shut down my containers, I will exit the VSL2 So now in a few seconds, my containers will stop and the VSL will stop, and I can exit this PowerShell. And thanks for watching. Have a nice day.